Hi, Jim Ison, Chief Sales and Marketing Officer at One Stop Systems here at SC22 in Dallas, Texas. Here with Seamus Egan, the Director of Government Solutions for TMGcore. So, great show so far. So tell us, what's TMGcore all about these days?
Yeah, well, TMGcore, we're headquartered here in Plano, in Texas, and our focus is on delivering high-performance compute using liquid immersion cooling. So liquid immersion cooling is a fast-growing space in the marketplace, and it's really geared towards enabling supercompute capabilities and doing that in a non-traditional context.
So I see we have the OSS Rigel supercomputer that's here on specs on there. It's a pretty high-end system of ours, boiling away. So how are we working together here at OSS?
Yeah, so this is a fantastic collaboration. So obviously here OSS has developed a small form factor, ruggedized, high-performance compute platform. This is ideal for partnership with TMGcore. So what we do is we actually take the system and we can actually deploy it inside of this dielectric fluid. These fluids are highly efficient from an energy perspective, and most importantly is we can do extreme densities in a small form factor leveraging these platforms. So this is the wave of the future. We're right on the cusp of it right now. When we look at the various chip technologies that are coming into the marketplace over the next 12 to 24 months, and we look at what NVIDIA is doing in their next generation that we will be collaborating on as well, it's going to be an awesome opportunity.
Yeah, you talk about that, the Rigel supercomputer here. It has 4 A100s in it, already 500 watts apiece, so 2,000 watts just in that. We have the next generation H100s coming watts apiece. I mean, we're talking monster amount of wattage, and the way that OSS works of bringing the power of the data center to the edge, we're being asked to put these things in applications that are, you know, from -40 to +70 degrees C, in some really edge applications where we need to put 12 different AI applications doing inferencing out in the edge in vehicles. So how do we get to that point when we're getting really high density?
Yeah, so the system we have here today obviously is a system that we use for demo and for benchmarking. We're working collaboratively on the next generation design. The beauty about the physics of these fluids is we can cool up to like 4,000 watts with a single liter of fluid. So what we're going to do is we're going to collaborate together to actually minimize and design a chassis, a two-phase chassis, optimized for the Rigel platform. And the beauty about this as well is that platform then will be scalable, so we can actually start with the A100s and then move to the H100s and then be able to take those into those austere type environments, both edge type deployments in a static context, like forward deploying for the US military as an example, forward operating bases, or as you described, mobile platforms as well with the AI Transportable solution.
Yeah, we really like to call this collaboration a disruptive technology, because putting this amount of horsepower into, say, a drone or into a military vehicle is really the next level that we're being asked to do. So every time I come by the OSS booth here, I see a host of people around this thing. So it's really seems to be attracting a lot of attention. So how's the show been?
The show has been fantastic, and obviously a lot of people, it's their first time ever seeing a two-phase immersion environment, but I think it's going to be a lot more commonplace as we move forward. I think everybody knows that Intel has just announced a $700 million investment to build a next generation data center. It's going to be based on liquid cooling technologies, and the good news for us is we're probably 2 to 3 years ahead in terms of actually already operationally deploying these systems into the field. So we hope that Intel catches up eventually.